Every machine has a beginning, a moment when it powers up, calibrates, and prepares for what's ahead. And every machine has an end, a safe shutdown, a memory flush, a silent returns to zero. In real systems, startup and shutdown are just as important as logic. And in C++, we build that with constructors and destructors. Today, we're going to bring objects to life. This is the moment that your code becomes a living system. So let's start by modifying our sensor class from last video. We're going to add something special to it, something that runs the moment a sensor is created. Okay? So before we write the class, first let's add include IOStream. Then using namespace std. Okay. Then we're going to write the class from last video. Okay. And then we're going to add private, and we add the private variable type float. Okay. So here, just to give you a recap, same as before, we store the internal sensor reading in a private variable called value. This simulates something like a temperature or pressure input. It's protected. Nothing can touch it directly. Why? Because it's in the private section, not in the public. In the public here, that's where the powerful, or that's where it gets powerful. We're going to add something called constructor. Constructor has the same name as the class and also has no return type, and it runs automatically the moment we create a sensor object. So we write class and, we write sensor and we give it the same as the class above, the same name. And then we open the bracket, and then inside, let's just call something like sensor powering on, and then running like a self-test. Okay, and then we end the line. Okay, and then we initialize a value like this, and we add a value of 0 as a float. Okay, done. So this is a constructor, same name as the class, no return type, and also it runs automatically once we create the object for that class. Okay, so let's go ahead and create the object. Integer main, and we create an object. Let's call it temperature sensor. Okay, and then we return 0 as we are done and successful. So we're done with the class. Let's test it out and see what happened. Okay. All right. Then we're going to run it. There it is. No function call, no setup line, just the object basically being born. And the message came straight from the constructor. So now let's add the destructor. The destructor is the opposite of the constructor. Okay. It starts with the tilde symbol with the name followed by the name of the class, same name. And here we go. So this function runs automatically when the object is destroyed, when it's removed from memory. In real systems, this is where you'd shut off the power or stop logging, release memory, whatever the hardware needs to go dark safely. Okay? And inside the function, we can just call the log of, let's say, sensor is shutting off or shutting down. Okay, shutting down. And then we end the line. Okay, now let's see if we can test it out. And we have the same, we keep the same thing, sensor, temperature, we call an object. And then here we can just add that the program or the system is about to finish. Okay, so we can just say cout system is about to finish. That's it. And then we end the line like this. Okay, and we return 0. So then basically the program finishes. And the moment this object disappears, our destructor runs. Got it? So let's see and test it out what happened. All right, here you go. So you've seen the full cycle now. Your object wakes up, does its job, and shuts down. It's just like a real machine. So let's upgrade our sensor. We still have the value variable, okay, in the private section, which stores the internal reading. But now we're adding another variable, and we'll give it a type of string, and we'll call it sensor ID, okay, a unique label. Like for a unique label, basically like temperature 1, gyro 3, gyro 2, just like how real embedded modules are tagged inside a system, okay? And in the public here, we're gonna create a new constructor, okay? We're gonna call it sensor like this. Notice here, the constructor has the same name as the class. That's how C++ knows that this is a constructor. But unlike before, which is the one on top, this time we're gonna add string ID. We're adding a parameter to it. So there's a difference between the first one, which is initialized constructor, and then the second one, which is parameterized constructor. Okay? And then inside that function, we're going to say sensor ID equal to ID. Basically here we assign the given ID to the sensor, and that gives every sensor object a personal identity. And then value, we initialize that, basically equal to 0. Okay, basically fresh start. We reset the value, fresh start, just like how embedded devices zero out memory on boot. Okay, and this line, basically we need to log the startup, right? And we can say cout here, and we can just say like, actually first we add the sensor ID. Not too fancy, but it's okay. Powering, for the sake of the example, powering on ... and then we end the line. Okay, so this line, we log the startup, right? Powering on. That's something that you would actually see in serial logs when a sensor boots. Okay. And in the main function, because we want to see and test it out and see the how this is gonna react. So let's delete that. Okay. So here we're gonna create what? We're gonna create two sensor objects. One is called temperature sensor. So let's say sensor, and then temperature sensor. Okay. And then we're gonna call it temp. Yep. We can just say temp like this, sensor like this, and then the second one we're going to add sensor, and then it will be gyro scope or gyro sensor. Gyro sensor, and then here we'll just call like gyro sensor, or just unite everything, gyro sensor, like this. All right, done. So then we say cout. Okay, something wrong here is that we're just calling the sensor class, so we need to call it correctly. Cout, and then we say system main, let's say program finished. Okay, and then we end the line, right? So let's test it, right? So we created two sensor objects. One is called temperature sensor. The other one is gyro sensor. These are like basically modules you'd plug into a board, okay? And watch, as soon as they're created, okay, their startup messages will appear. And let's see how that goes. So we save that, and then let's run it. All right, so here you go. So what do we have here? Okay, we have each object, okay, booted with its own identity. Then when the program ended, they shut down in reverse order. This is the power of parameterized constructors. You build the blueprint once, but you create dozens of uniquely configured modules from it. It's the same principle used in robotics, aerospace, medical systems, or devices. Every sensor might follow the same rules, but each one knows who it is. Let's step back for a second and look at what we just built. In just a few minutes, we wrote a class that simulates a real machine module, a component that boots up, stores its identity, updates its state, and shut down safely. So on the left side, this is how most beginner code starts. A list of global functions floating in space. They work, but they don't belong to anything. Now on the right side, look at this. Instead of those loose functions, we have a self-contained object, one that knows what it is, one that holds its own state, runs its own startup, and even shuts itself down. Without objects, everything is global, floating, scattered. Each new feature adds more mess, more risk, and even more bugs. But with objects, every part of your system is modular, contained, and self-aware. Okay. With procedural code, your system never remembers anything. It just reacts like reflexes, no memory, no brain. But with objects, your modules think. They hold on to state, they follow their own logic, they boot, respond, and power down like machines really do. And this is how modern embedded systems are actually built. Whether you're working on drones, satellites, or medical implants, or even brain-machine interfaces, everything is modular. Each component is an object, and each object is a brain. And together, they form a system that thinks. So far, we've seen how we go from functions to objects to machine modules that wake up, respond, and shut down. But a real intelligent system doesn't stop at one object. It has dozens, maybe hundreds working together. Each module has a purpose, but some share common traits. Like for example, a gyro sensor and a temperature sensor, they both need calibration, reading, display functions. And that's where we enter inheritance, the idea of a base class, a blueprint of a system component, and specialized classes that extended it. One class defines the interface, another adds the mission. So in the next video, we'll create our first control hierarchy, a system where a single command center controls multiple sensors and actuators using the idea of inheritance. And we'll be using inheritance, abstraction, and polymorphism, the foundation of a real-world embedded control system. So subscribe, because now we're not just building objects, but we're building machines that think.